Hello everyone, welcome to Spectra Education. Myself Dr. Rajeshwar Panja, and we are discussing about the mathematical physics for the B.Sc physics students. Today I am very excited because today I think this video is going to be very interesting because I have planned to discuss about how to solve almost any type of problems related to the gradient. গ্রেডিয়েন্ট সংক্রান্ত প্রায় যত রকমের প্রবলেম হওয়া সম্ভব তার সলিউশন কিভাবে করবে সেই নিয়ে আজকে কিন্তু আলোচনা করব। And what is the purpose or aim of this video? The purpose is not to provide different problems with solution, but to teach you how to solve any known or unknown problems regarding the gradient. जे कोनो प्रॉब्लम तुम्हें किभाबे सॉल्यूशन करते पारबे, कोई भी प्रॉब्लम हो कैसे तुम सॉल्यूशन कर पाओगे, दिस इज द मेन एम ऑफ दिस वीडियो। ठीक है, अगर ये वीडियो पूरा कंप्लीट कर लोगे सो आई बिलीव that after finishing this video you will be able to solve any type of problems regarding the gradient. So according to my plan I have divided all problems in two types, two broad categories. First I will discuss 1 to 2 problems related to the simple type of problems, and the second type of problems where we need some important concept. So through solving any problem I will also focus how to develop the important concept, okay, and some problems where some formula is needed. So through solving problems we will also learn the formulas. So for that we don't need to memorize anything. So let's start with the simple problems. So first problem, here you can see that first problem where a scalar field or you can say scalar function is given and it is asked what is the gradient of that field, where at the particular point 2, -2 and -1. So this problem is very simple, and just recall what is the meaning of this gradient of phi. देखो वीडियो थोड़ा लंबा हो सकता है क्योंकि मैं each and every problem I will explain the concept, I will try to develop the physical meaning etc, by which you will be able to solve any problem. You don't need to solution from anywhere, okay. So this is the aim. So for that the video may be little bit lengthy, okay. चलो तो फिर gradient का मतलब क्या है, what you have learned, what do you mean with gradient? Gradient means at that point 2, -2 and -1, थोड़ा सा just recall कर लो कौन सा point 2, -2, it is x, y and z. X is along this x axis, this is 1 unit, let's say this is 2 unit, and then you have to move along this negative y axis, this is 1 unit and this is 2 unit, and you have to move z direction -1 unit. So this point, so this is the 2, -2 and -1. At that point along which direction this phi is changing rapidly, this is the meaning of the gradient of a scalar function. So mathematically it is very easy. So क्या चाहिए हमें, we need to solve this gradient of phi. So gradient, first write down the expression of nabla, I cap del del x plus j cap del del y plus k cap del del z, which will be operated on the given function twice x z to the power 4 minus x square y, okay. अब चलो, so this I cap del del x for the first problem I will solve explicitly, later on I will skip certain parts, okay. So del del x will be operated on the whole function, that is 2x z to the power 4 minus x square y plus j cap del del y, which is also operating on the whole 2x z to the power 4 minus x square y plus and k cap del del z, this is 2x z to the power 4 minus x square y. And as you all know, this is a partial differentiation, it is very simple to solve that one. So del del x will only operate on the x term and the rest of the terms remains constant. So first I cap, so del del x will operate on 2x z to the power 4, so 2 z to the power 4 remain same, so del del x of x is 1, so it gives you 2 z to the power 4 into 1, right, minus, so del del x on x square it gives you 2x y as it is, plus j cap del y. So del y will operate only the y term, but in this first term there is no y, so it gives you 0 because all these 2x z to the power 4 all are constants for del y, minus del y operate on y, it gives you 1, so x square into 1 plus k cap del z. So del z will operate on the z to the power 4, it gives you 4 z cube, so 4 into 2 is 8, so 8 x z cube minus del z. Is there any z term? There is no z term, so it gives you simply 0. So this becomes I cap 2 z to the power 4 minus 2 xy plus j cap. It is I think it should be, if we take it is minus, so it will be minus x square j cap or j cap x square, whatever we can write, and here it is 8x z cube k cap. Okay, so this is the gradient of phi, but we have to find out at the point 2 minus 2 and minus 1. So I cap 2, in the place of z we will use this minus 1, so it is minus 1 whole to the power 4 minus 2 into what is the x value? X value is 2, so x value is, so it is basically gradient of phi at that point, that is 2 minus 2 minus 1. So 2 into 2, y is minus 2, so this is the first term, plus x square. X square means 2 square j cap plus 2 into x is 2 and z is equal to minus 1 whole cube, which is k cap. So this basically I cap, and here it is minus 1 to the 4 is 1, so 2 minus this minus and this minus will be plus, so it is here 8 plus 2, that is 10, so this is 10 I cap plus 4 j cap, and here it is obviously minus 4 k cap. So it is 10 I cap plus 4 j cap minus 4 k cap, and you have to find out what is the magnitude of this gradient of phi also. So let's take another page. So here we can take some pages. So here what we have found out, we have found out that gradient of phi at the point 2 minus 2 and minus 1, it is 10 I cap and it is plus 4 j cap minus 4 k cap. So plus 4 j cap minus 4 k cap, right? So what is the magnitude of this phi, okay, at the same point? Magnitude means, for example, if a is equal to x I cap plus y j cap plus z k cap, so what is the magnitude then? So magnitude of this vector, as you all know, that it is x square plus y square plus z square. Okay, so that means it is the square root of the summation of square of coefficient, যে coefficient গুলো আছে তার summation. So it becomes, it will be root over 10 square plus 4 square plus minus 4 square. So these are the coefficient of I, j and k, right? So what is the answer? It is 100, it is 16, it is 16, so it is 132. So कभी कभार क्या होता है कि कुछ कैलकुलेशन में गड़बड़ हो जाते हैं, तो इसको चेक कर लेना, ठीक है? It is 16, it is 16, 32, so it is 132, और इसको चाहो तो और भी सिंप्लीफाई कर सकते हो, कर लेना इसको सिंप्लीफाई, ठीक है? चलो, so next move to the next problem. This is another simple problem, right? So this is here, it is given gradient of, it is also again wants to find out this gradient of phi, but phi here it is given as log magnitude of r vector. what it means. As we all know that r vector is the position vector, right? So that means it is x I cap, এটা বলা থাকুক বা না থাকুক, r vector means the position vector, y j cap plus z k cap. So what is the magnitude of r vector? Just we have done this one. It is nothing but x square plus y square plus z square, or we can write it is as x square plus y square plus z square equal to the power half. Same thing, right? Okay, so now we can write that phi is nothing but ln x square plus y square plus z square equal to the power half. So ln these things means we can write it is half log x square plus y square plus z square, right? Very simple. Okay, so now find out this one. So we have to find out the gradient of phi. So gradient of phi means I cap, as you all know that del del x, this term, that means half. So right now I am not writing explicitly that what is the nabla, what is the phi, then each and every term will operate on the phi. तो मैं completely लिख रहा हूँ, समझ लेना इसको, ठीक है? एक साथ हम लिखिए एटाके, ठीक है? So it is ln x square plus y square plus z square. Similarly, the second term will be j cap term, and it will be del del y. It is again the same thing, ln x square plus y square plus z square, and the third term is j cap del del z. It is again half ln x square plus y square plus z square. Now it is very simple, only the partial differentiation. So we can take this half here, half and half as a grand common. So it gives you that I cap. So del del x will only operate. So del del x of whole term ddx of log x is 1 by x. So it gives you 1 by x square plus y square plus z. So simple differentiation with respect to x. So then according to chain rule, del del x of x square, so it gives you 2x. Okay, plus similarly j cap, again we will get 1 by x square plus y square plus z square into 2y plus k cap, 1 by x square plus y square plus z square into 2z, right? So if I take 2 here, 2 here and 2 here, so this all 2 can be cancelled by this 2. So the terms remain x I cap plus y j cap plus z k cap, and the denominator will be x square plus y square plus z square, right? So what is the above term? It is nothing but the r vector. And what is the denominator? Horta ki denominator is nothing but r square, right? Because r magnitude of r is this one, that is r. So r, this is r square. So we have found out r vector is equal to r square. So for that, the part B, I will only gives you hints. ठीक है? मैं एक hint दे रहा हूँ, उसके depend कर लेना. It is very simple because phi is given. Phi is equal to 1 by r, right? R means the magnitude of r. That means this one. Okay, that means this one. So it means nothing but 1 by x square plus y square plus z square equal to the power half. So if we write, we can write it is at x square plus y square plus z square equal to the power minus half. So this is our phi. So what is the gradient of phi? So same I cap del del x, then this function will be here, j cap del del y, then again this function will be here inside the bracket, and so on. So if you solve properly, I will give you only the answer here, but I believe that you will do that one. और कमेंट करके मुझे बताना कि तुम किए हो कि नहीं किए हो. देखो अगर तुम खुद नहीं करोगे तो मुझे भी इतना इंटरेस्ट भी नहीं मिलेगा, है ना. सो खुद करते रहो, क्योंकि my aim is not to provide you the solution, my aim is to provide you the proper concept. So the answer will be gradient of phi. For that case it is minus r vector by r cube. So these are the two simple problems. Later I will discuss some problems with the concept. Okay, so let's take the these problems. So problems with concept and formula. So first there is a formula. We have to prove that one gradient of r to the power n, it is equal to n r to the power n minus 2 r vector or n r to the power n minus 1 r cap. Okay, so sometimes in your college examination or some competitive examination, this type of direct proof is demanded there. ঠিক আছে, কিছু কিছু কলেজ পরীক্ষাতে ডাইরেক্ট প্রুফ করতে দেওয়া হয়. সো হাউ টু রিমেম্বার দিস ফর্মুলা? দেখো, দিস ফর্মুলা ইজ নট ডিফারেন্ট ফ্রম ইউর নর্মাল ডিফারেন্সিয়েশন. ইউ অল নো দ্যাট DDR of r to the power n, it is nothing but n r to the power n minus 1, right? So you can find out this term is also here. So you can think this is the differentiation because it is nothing but the vector differentiation. Okay, so this term is already here. Gradient of r to the power n means it is simple DDR of r to the power n, so n r to the power n minus 1. But since it is a vector differentiation, so some vectorical term should be there, so r cap is here. But if you want to avoid this r cap, so if you write down this gradient of r to the power n in terms of r vector, then this power will be changed by 1 unit, that is it will be n minus 2. So I will prove that one. It is very simple. So let's do it. And I will also request you, please take a pause for 2 to 3 minutes. First try to solve by yourself, then follow this solution. So gradient of r to the power n. R to the power r means in vector, r means the position vector. So it is x I cap, y j cap plus z k cap. But gradient is basically associated with the scalar function. This r means not r vector but the magnitude of r to the power n. So magnitude of r, so r is equal to magnitude of r vector. We all know that it is nothing but x square plus y square plus z square whole to the power half. So what is the r to the power n? It is simple, x square plus y square plus z square whole to the power n by 2. Okay, so now this is nothing but this gradient of x square plus y square plus z square whole to the power n by 2. So we will write explicitly with the expression of nabla, that is I cap del del x of this term x square plus y square plus z square whole to the power n by 2 plus j cap del del y x square plus y square plus z square whole to the power n by 2. एक एक टर्म को लिखते जाना भाई, क्योंकि स्किप अगर कर दोगे ना तो प्रैक्टिस पे कम हो जाएगा, और प्रैक्टिस अगर कम हो गया मतलब यू विल नॉट लर्न. ओके, प्लस के कैप डेल डेल जेड एक्स स्क्वायर प्लस वाई स्क्वायर प्लस जेड स्क्वायर होल टू द पावर n by 2. अब एक एक टर्म का पार्शियल डिफरेंशिएशन करो. अब तो इट इज वेरी इजी टू सॉल्व दैट वन. सो इट इज आई कैप del del x of this to the power n by 2, so it is n by 2. Okay, and this to the power x square plus y square plus z square to the power n by 2 minus 1, right, into again according to the chain rule del del x of x square, so it gives you 2x plus similarly you will get here n by 2 into x square plus y square. Oh, this will be I cap term, so this will be j cap term, right. So x square plus y square plus z square whole to the power n by 2 minus 1 into 2y, and the k cap term the same thing. I am not writing repeatedly, so this will be the same to the power n by 2 minus 1, and here will be 2z, right? So let write together. Okay, so what we will get? So these two cancel. Okay, so what you will get basically here? So here we can take this n, all the n's as a common factor. So n will be here, and we can write this one as x I cap divided by, we are writing this one in two form. One is x square plus y square plus z square whole to the power n by 2, and in the denominator it is x square plus y square plus z square. So then basically it gives you this term, right? So similarly here you will get y I cap, right, into same term x square plus y square plus z square whole to the power n by 2, and in the denominator x square plus y square plus z square, and here also it is z k cap, the same term to the power n by 2, and here it is same term, right? Okay, so what basically we are getting, this is common for all the terms, right? So we can take this n x square plus y square plus z square whole to the power n by 2. So here x I cap plus y j cap plus z k cap, and in the denominator it is x square plus y square plus z square, right? अब देखो x square plus y square plus whole to the power n by 2, what is this? This is nothing but r to the power n, so we can write it is n r to the power n, right, into the numerator is r vector, so we can write this r vector, and denominator it is nothing but r square. So it is r to the power n, it is r square. So can we write it is n r to the power n minus 2 r vector? So the first proof we have done. So gradient of r to the power n, if we want to keep it in terms of r to the power r vector, so then it is n r to the power n minus 2. Okay, so now we will prove that one, it is again also n r to the power n minus 1 r cap. Okay, so for that, so what we have found out? We have found out gradient of r to the power n, it is n r to the power n minus 2 r vector. So again we know that it is n r to the power n minus 2. What is the r vector? R vector is nothing but magnitude of r into r cap, right? Because any vector, a vector, we can write what is the unit vector of this a vector? N cap. This is the unit vector, is a vector by magnitude of a vector. So it is nothing but a vector by a. So what is the a vector? A vector is the unit vector into a. So similarly, what is the r vector? R vector is r cap. Okay, so this is r to the power n minus 2, this is r to the power 1. So if we write together, so it gives you r n minus 1 r cap. So is not it simple? So now our formula is complete, that is gradient of r to the power n, either we can write it is n r to the power n minus 2 r vector, or it is equivalent to n r to the power n minus 1 r cap. So I will suggest you, if you just remember this one, because it is quite similar to ddt r of r to the power n, right? So if you remember that one, you can easily move in this way. So let's take one simple example based on this formula. একটা example এখান থেকে নেব, তাহলে আরো ক্লিয়ার হয়ে যাবে। Okay, so let's take one simple formula. Okay, so it is asked that gradient of magnitude of r to the power 3. So it is simple. Gradient of magnitude of r to the power 3. Magnitude of r is means x square plus y square plus z square whole to the power half. It is the magnitude, and whole to the power 3. So it is basically gradient of x square plus y square plus z square whole to the power 3 by 2. Is not it? Sorry, I don't think you don't need to do this one, because you can directly use the formula, because it is nothing but it is equivalent to gradient of r to the power 3, right? So we have gradient of r to the power n, it is n r to the power n minus 1 r cap. So similarly you can write it is 3 r to the power 3 minus 1 r cap, or it is 3 r square r cap in terms of r cap. But if you want to keep in terms of r vector, so this is, it is n r to the power n minus 2 r vector. So here 3 r to the power 3 minus 2 r vector, or simply it is 3 r r vector, right? So both are same. Very simple. So let's take another example. Okay. This is a problem of where we can generate different concept. ये जो प्रॉब्लम है ना, इसी प्रॉब्लम से एक दूसरा कॉन्सेप्ट वी विल जनरेट. तो यहीं से हम लोग कल से स्टार्ट करेंगे. आज थोड़ा डिस्कस ये कर लें क्योंकि वीडियो बहुत लंबा हो जाएगा. सो एट दैट मोमेंट आई थिंक दैट वी शुड स्प्लिट आवर वीडियो 2 to 3 डिफरेंट लेक्चर्स. ओके, नहीं तो बहुत लंबा हो जाएगा क्योंकि एक एक प्रॉब्लम को अच्छी तरह से सॉल्यूशन करेंगे. देखो कि ये जो प्रॉब्लम बोल रहा है ना कि सो दैट ग्रेडियंट ऑफ फाई इज अ वेक्टर परपेंडिकुलर टू द सरफेस फाई एक्स वाई जेड सी. देखो एक बोल रहा है कि एक सरफेस दिया हुआ है. सरफेस मींस एक प्लेन दिया हुआ है. कहाँ? 3 डायमेंशनल कोऑर्डिनेट सिस्टम में. ये मान लेते हैं कि एक्स वाई एंड जेड. सरफेस किस तरह की सरफेस है? सरफेस का इक्वेशन जो है इट इज कांस्टेंट. तो मान लेते हैं कि एक जो एक आर्बिट्ररी सरफेस व्हिच इज फाई एक्स वाई जेड इज इक्वल टू सी. Or you can think simply, you can think one spherical surface, जैसे x square plus y square plus z square is equal to some constant, let's say it is 9. ये क्या है? एक sphere होता है ना. So for this type, अगर कोई भी surface, if any surface is represented by this equation where the right hand side is constant, left hand side is a function of xyz and right hand side is a constant, for this type of surface, if you take the gradient at any point, for example let's say at that point P, this gradient will always be perpendicular to this surface at that point. This is the concept. What is the concept? कि अगर कोई भी प्लेन इस टाइप की इक्वेशन से रिलेटेड है, ठीक है, इफ एनी प्लेन इज रिप्रेजेंटेड बाय दिस टाइप ऑफ इक्वेशन, तब उसी प्लेन के ऊपर कोई भी पॉइंट पे अगर ग्रेडियंट निकलना चाहते हो तो ग्रेडियंट जो होगा, दिस ग्रेडियंट शुड बी परपेंडिकुलर. ये है ग्रेडियंट ऑफ फाई की डायरेक्शन एट द पॉइंट पी. मान लो कि कोई दूसरा पॉइंट क्यू चूज कर रहे हो, क्यू पॉइंट में जो परपेंडिकुलर डायरेक्शन होगा इस प्लेन की, this perpendicular direction is the gradient of phi. So at each and every point gradient of phi will be perpendicular or will be normal to the surface. But what is the condition? Condition is that the surface must follow this formula. तो चलो एग्जाम्पल में दिखा रहा हूं, इसको प्रूफ भी करेंगे नेक्स्ट वीडियो में और फिर वो एग्जाम्पल सॉल्व भी करेंगे. तो चलो एक तुरंत जस्ट टू गेट एन आइडिया. देखो एक सरफेस दिया हुआ है इधर, एक्स स्क्वायर वाई प्लस 2xz इज इक्वल टू 4. एक्स स्क्वायर वाई प्लस 2xz इज इक्वल टू 4. अब ये लेफ्ट हैंड साइड क्या है? इट इज नथिंग बट 5xyz, क्योंकि ये एक्स वाई जेड की फंक्शन है और राइट हैंड साइड इज अ कांस्टेंट. सो इन दिस कार्टेशियन कोऑर्डिनेट सिस्टम एक्स वाई एंड जेड, मान लो कि दिस सरफेस इज लाइक दैट. बेसिकली ये ऐसे ही होते हैं अगर ठीक से प्लॉट करोगे तो. सो दिस इज द सरफेस एट द पॉइंट 2, -2 एंड 3. कोई पॉइंट ये 2, चलो मान लो कि ये 2 पॉइंट है और ये -2 एंड 3, मान लो कि ये पॉइंट, ये P पॉइंट एट 2, -2 एंड -3. यू हैव टू फाइंड आउट व्हाट इज द नॉर्मल एट दैट पॉइंट. इसी पॉइंट में नॉर्मल क्या है, व्हाट इज द एक्सप्रेशन ऑफ द नॉर्मल और व्हाट इज द मैग्नीट्यूड ऑफ द नॉर्मल. व्हाट वी नो फ्रॉम द प्रीवियस डिस्कशन कि अगर कोई भी सरफेस फाई एक्स वाई जेड इज इक्वल टू कॉन्स्टेंट, जो कि ये जो सरफेस जो दिखा रहा है इट फॉलोज दिस रूल. इसी सरफेस के ऊपर कोई किसी भी पॉइंट में नॉर्मल इज नथिंग बट उसी पॉइंट में इस जो फंक्शन दिया हुआ ना उसका ग्रेडियंट निकाल लो. सो इफ यू डू द ग्रेडियंट ऑफ एक्स स्क्वायर वाई प्लस 2xz at the point 2, -2 and 3, this is the normal of the surface at the point. तो इसके बारे में नेक्स्ट वीडियो इन डिटेल्स डिस्कस करेंगे, एक एक कंसेप्ट को समझ लेंगे. सो वेट फॉर द नेक्स्ट ভিডিও. বাকি নেক্সট ভিডিওতে আরো নতুন নতুন কনসেপ্ট এবং প্রবলেম নিয়ে আমরা আলোচনা করব. ओके, सो दैट्स ऑल फॉर द डे. आई थिंक यू हैव एंजॉयड. अगर छोटा सा हो सके तो छोटा सा कमेंट कर देना, लाइक कर देना, क्योंकि इट गिव्स मी सम encouragement to make videos for you. So that's all. We will meet again. See you. Bye bye.